Hi, good morning and good afternoon, everyone. Thanks for joining us today for this new webinar by the Several Nines team. We're joined by a special guest, and I'll introduce Riaan in a second properly. But I just wanted to give you a quick run through of some of the logistics for today's session. If you have any questions during the next 60 minutes or so, feel free to ask them in the question section of your control panel. You can also use the chat box if you like. And if you have questions following this webinar, feel free to email me at jj@several9s.com, and we'll make sure to look after you via email as well. The session is recorded, and we will make the slides and the recording available to you over the next couple of days once we finished up for today. But for now, we're live. And the topic, if we go to the next slide, is first of all, a quick introduction to Several Nines and Cluster Control. We're a company that specializes in automation and management of open source databases. And we do so with a product called Cluster Control, which focuses on these 4 key areas, which are the deployment, monitoring, management and scaling of open source databases. Within the product, you've got a community version that allows for the deployment and monitoring, which is free. And there is a commercial version that also includes management and scaling features, which you can test for 1 month in the community version when you first download it. We have these are the kind of the key areas that we focus on with Cluster Control around provisioning, monitoring, and management. Some of the key features that the system provides. We've got over 12,000 users today who use Cluster Control to manage and automate MySQL, MongoDB, and Postgres. So these are the data stores that we support in the different versions and flavors. And these are the users, some of the users that work with us across the globe. This is just to give you a quick overview of who we are and what we do. And hopefully you're already Cluster Control users, and if not, you might want to check it out after this webinar and see what you think of it. But for now, we're live with a topic all around DevOps. And before we get started with that, I wanted to ask all of you a quick question, which is all around DevOps as well, or rather, it's to ask you how you would describe your role currently in your company, just so we know who we have with us today. Whether you are a DevOps professional yourself, or maybe you're a system administrator. Maybe you feel you're both, or maybe you're a DBA, or none of the above. Actually, that could be the case as well. It would be great to get your feedback here. I'll just let this run for a few seconds, and then I'll share the results, so you can all see what type of a mix we have today in the audience. So thanks for your participation here. It looks like everyone's provided their feedback, so thanks very much. I'm just going to close this now and share the results. Great and interesting. So it looks like we have a lot of DBAs on the call today, which is great. And some of you are system administrators, some of you are system admins and DevOps, a combination of both, which maybe isn't too surprising. They can be considered to be kind of the same thing. So that's interesting to see. Thanks very much for your participation in this poll. I'm just going to hide this now, and then we can get back to the slides. Art, and just to introduce you to our speakers today, we have Riaan Nolan, who very kindly agreed to join us today from South Africa, and Riaan works for a company called Mukuru.com. And Art van Skeppingen, who is a colleague of mine at Several Nines, one of our senior support engineers. And Riaan and Art will talk about how to automate your database infrastructure from a DevOps perspective. And I'm going to hand over to the two of you. Thanks very much.
Thank you very much, JJ. So, first of all, the agenda today is very brief. We are going to talk a bit about DevOps and databases. What are the main challenges here, and what do we face with DevOps when we're using databases? We're going to speak about databases in the DevOps environment. How would they well, how would you manage them in such an environment, and why is it different from a normal environment? Then I'm going to talk a bit more about data distribution, which is it has to do with the way the world is changing at the moment, and that kind of bridges to the cloud automation on AWS that's presented by Riaan. And at the end, we have a short demo on the DevOps features within cluster control. So first of all, what are the DevOps and databases? What challenges do we face at the moment? Well, to begin with, there's a very different approach to development and ops in DevOps, and that's also where the abbreviation comes from. We have a development side and we have an ops side, and ops obviously wants to keep everything running and ensure that everything gets deployed properly, while development wants to create and deploy as quickly as possible. And since these two have to collaborate much better together in a DevOps environment than in a traditional, let's say, waterfall development, where basically development drops a new version of the application after 4 or 5 months of development, you now are going to iterate over these development cycles quite often. So let's say release every week, maybe every 2 days, depending on the way you work. And to facilitate this more frequent development cycles, DevOps really needs to cooperate together. Now, databases well, they don't really fit into this picture because they're mostly built around security and integrity of the data. They really want to maintain the integrity of your data at all costs. And that means that, for instance, schema changes are really slow to apply. They will create locks in your system, and that obviously halts a new development drop of the application. Also, the more frequent you are going to apply changes to a database, the more inevitable it causes production issues. So how would you provide an environment that actually facilitates things better? Of course, in DevOps, NoSQL is king nowadays because of its schemaless design. However, a lot of people are realizing that there is a big trade-off with NoSQL, where they have chosen flexibility over the consistency. So the schemaless design also means that you have to maintain your own schemas, and that also means that within the code you actually have to maintain the schema instead of the database itself. Applying indexes to a NoSQL database might be a bit troublesome depending on the NoSQL database that you're using. So there are trade-offs to make there. Now, the big question is, where does the DBA fit in DevOps? And I can briefly say the DBA doesn't fit in DevOps. It sounds really harsh, but DevOps doesn't provide a role like a DBA. And that's because the DevOps roles are less clearly defined. DevOps is now involved in operations. They also are involved in the release cycle. And Ops is also actively involved in the development release cycles by providing a platform that allows frequent deployments, also maintains configurations, knows a bit about the application, how it functions, and the whole team shares the responsibility. And the DBA is basically not a role that fits into this picture. It's too specialized. However, the DBA role is being driven by the developer, by initiative and changes, and increasing the performance of the application inside the database, while the ops side will actually start to handle consistency and security. So also the DevOps role of both developer and ops, they have to know a bit more about databases and about the internals. And because in most DevOps environments, the people involved are more specialized in the application that they're running, they will also know a bit more about the database. Well, what challenges can we find there for databases in DevOps? Well, I named a couple of them earlier. Because of these more frequent release cycles, the continuous deployment needs more environments to be deployed for the developers to build against or to test against. If you're going to spin up a new environment for a development team to develop against or to start acceptance tests, you also need to provide database copies of production. You need to obfuscate data that's inside this database. And one other aspect, and that's what we're going to highlight later on, are microservices that do not share the same ideas than a relational database. Microservices have a shared nothing architecture, so most of the time they just are a single table with maybe a few columns and no more than that. And that's everything there is for a microservice to use as a storage. And this is quite differently from traditional relational databases where you have a relational schema and integrity rules, while for microservices that may not be the case. This also leads to the problem that not only the developer has to know a lot about the database, but also the ops needs to know a lot about the database. And if they don't communicate properly, they will have issues deploying the latest version, schema changes that may not be applied properly. So that means that they need to communicate very well. And every team member then needs to be updated on what are we going to deploy, when are we going to deploy, what is the current deployment plan, is there any issue currently happening, and maybe we can step in and help out. So collaboration tools here can help, and we'll zoom into that as well. I'm now going to hand over to Riaan, because he's going to talk a bit more about the challenges from the DevOps side.
Good morning, everyone, and greetings from South Africa. I'd like also to, before I begin, wish you a happy Nelson Mandela Day. He was our first president after apartheid, and he's still very dear in all of our hearts. And so, so happy Nelson Mandela Day. Thank you, Art, and thank you, John. Touching on what Art has said about the challenges in DevOps, and so for me, one of the challenges when I start at most companies is to get hold of all of these credentials that have already been created, perhaps in legacy applications, and in most cases when there were no automation. So once we get hold of all of these credentials, we can put them into, and I'm going to use Puppet for this example and Hira because that is just the tool of choice for me, or CloudFormation. We can then put these credentials into Hira, and we can have them on hand without yet managing these resources. You can store these credentials securely encrypted with Hira and YAML, and then you can also make them available. One of the tools I use is a composer package from vLucas, and it's called .env. Basically, this would just write a small .env file that the application can auto-load, and it can then get its credentials that way. So we do not need to embed our credentials in GitHub or share them unencrypted, clear text, none of that. Then another thing that Art touched about is this loose coupling between developers, DBAs, and DevOps. So quite often what I find is developers push new code, they are not hitting the indexes, and then the database CPU load goes through the roof. DevOps doesn't know about it, and the DBAs doesn't know about this either. So then what happens is some troubleshooting, and we eventually get to what is causing this. The developers create an index, or they push some new code, and the problem is gone. It's so easily forgotten though. So one of the things that I like what Art mentioned is these feedback loops. To help me in my organization, we use Slack, and many companies do, or they use Skype or some form of chat program. So what I do is I use Capistrano to push code to servers, and Capistrano just pushes a little message, a deployment message, into a Slack channel. Lets you know that this developer has released this branch onto that environment. This helps everyone because if we see locks or CPU load going through the roof, we can always just go to the auto scaling channel, see who deployed code last, go look at this branch, and automatically quickly everyone is connected and they're on the same page. Another thing that I do is I use for monitoring, I use CollectD, and there's a beautiful little plugin. It's a Slack client integration for CollectD. 4 lines of code in CollectD will let you push notifications again to a Slack channel. This is handy when database connections goes to the roof, load spikes. All I do is I then watch CloudWatch. I have a little Ruby script that just gets some CloudWatch values and metrics using the AWS CLI tool. And all that it does is it relays this into Slack. It's not a big chunk of work to do this, but the value that these little tools provide, you will find that helps a lot. In my case, certainly, because all of a sudden, everyone is in the know. Then once you have these resources under control and managed, we need to start monitoring them. So some of the tools I use is Kibana, and I also integrate this with CloudWatch logs, CloudTrails, and VPC flow logs. Then certainly New Relic has to be mentioned here. It is a DevOps guy's best friend. I think every developer should use New Relic. And then CollectD, of course. And I'm going to now hand this back to Art to carry on with his presentation, and he will connect with me again a little bit later.
Okay, thank you, Riaan. So I'm going to talk a bit more about managing databases in a DevOps environment in general. So I've spoken earlier about microservices and about their architecture, and the impact is actually quite big compared to a traditional application where you have one giant monolith or a very big interface that provides an API. Microservices are really small, tiny services that will only have one purpose. So these microservices are becoming really popular among DevOps because they're easy to deploy. They don't share anything with other microservices. They have a strong cohesion, so they solve everything themselves. And they have a loose coupling. They don't interact with other microservices other than using the API of other microservices. They have a shared nothing database, so they have their own simple schema. Like I said, maybe one table, maybe 2 tables, depending on their design, but preferably just a very simple schema to store anything. And the idea is that their backend should be interchangeable with any other storage system. So if you, for instance, develop your microservice on, let's say, MySQL, then it should also be relatively easy to migrate that to, for instance, MongoDB, because MongoDB has a very good sharding scheme and you want to migrate it to that. All you have to do is simply change the backend code of your microservice, but the front end doesn't change. The API doesn't change at all. The problem, however, is that between microservices, joining data might be a bit more troublesome. So if we would take this example, for instance, where we have multiple APIs where we are connecting to these microservices in the back, they cannot read or shouldn't read from other data stores than their own. In the example that I've given here, that's clearly wrong, where we have a login service that is getting the details from the user details MongoDB instance, and the same for the billing, it's getting the details from that database directly. And this is something that shouldn't happen. And the reason why is if the user details microservice would change their backend for some reason, or they would all of a sudden start sharding data while the login service or billing service isn't aware of that, everything would go wrong. So the correct way would be that these services would then use the API of the user details microservice. And that way you make it transparent for the microservices to interact with each other. And they just know the API of the other microservice that they need to call. And that's everything they should know. And they shouldn't know anything about the infrastructure behind the other microservices. So the proper way would be using the API itself and then For instance, we have the user API here joining the data between the login microservice and the user details microservice. And even the website itself should be joining data between the billing API and the user API. And that's the way microservices work. It does have a couple of drawbacks, obviously, because you cannot immediately join the data between the 2 or 3 data stores in one single call. And that also means that there is a certain sacrifice made here. The positive side is that if the user details microservice, for instance, would suffer from issues with the backend, the other microservices are still functioning independently, and then the user API should be resilient against the user details microservice being down, for instance. And you can use generic error handling like HTTP error codes that can be interpreted. That's just an example. It depends on your API, obviously. This abstracts the databases away from both the APIs that are user-facing and also from the individual microservices. And that means that these microservices now can be individually changed, and you can use any data storage that you would like. And also, if you want to migrate to a different data store, you could do that in parallel with a running database at the moment. Now, automated deployments is another issue that I've named earlier onwards. If you want to provide a new environment for release or development testing, or for instance for disaster recovery or testing your disaster recovery plans, you need to spin up a full environment of the application, including all the databases. And it also means that your database deployment also needs to, in addition to deploying the database software itself, it needs to restore a production copy, for instance, or take the backup from the previous night, install necessary packages, helper software that is necessary, create users, add it to load balancers or set up even these load balancers. And this also means that you need to automate a lot. And if you want to do this by hand, it probably would take you a couple of hours to provide a new environment to let's say, one of the teams, which is not very useful if you want to do this on a daily basis or maybe on a weekly basis, depending on the way the developers work. In some cases, even developers may use their own personal environment, which they need to spin up and create within maybe a couple of minutes and then throw it away to test it on a different operating system. And this obviously takes a lot of time if you want to do that all by hand. Now, there are perfectly fine automation frameworks here. Riaan also mentioned Puppet. It's one of the most used automation frameworks. There's also Chef, which is in essence the same as Puppet, but it has a different feature set. And Ansible, it has a different methodology. It's more like scripts that you run against a set of hosts instead of managing everything from a centralized point like Puppet and Chef do. Another thing that I mentioned and Riaan mentioned earlier is performance monitoring. Performance monitoring provides insights for the entire team. How is their application performing? And the best way to do that is create dashboards or create insights around these applications and services, that everything is within one single view and that you immediately can see if something is going wrong. Then you can incorporate existing application service metrics here with the detailed database metrics, and combine the two of them. You can immediately see if there are problems going to happen. So preemptive troubleshooting would be possible then. But you can also correlate metrics between, for instance, the number of requests coming in and the database load, or if you can see that the latency is going up, and you look at InnoDB performance, and you can relate that to each other. Now, the application monitoring that Riaan mentioned earlier, like New Relic, it lacks database performance metrics, so you need to enrich that. These application performance monitoring systems are very useful to see what is actually happening inside the application, but it's only the insights from the application point of view. So if you would add the insights of the database itself, that would provide a lot more information than just the application performance monitoring systems. Another thing that I mentioned earlier was schema changes. Schema changes, well, I don't say that they're necessarily going to happen frequently, but if you have a lot of microservices, there's bound to be like a schema change every week maybe. And that also means that if you make frequent changes to schemas, you need to do that in, let's say, an automated way, because doing everything by hand may not be the best option to do here. A problem that you often see with schema changes are object relational models that are being used as a piece of software to connect to the database and also provide the schema. And these frameworks actually require create and alter rights a lot of times. And if you would provide create and alter rights on a production system, that also could mean that the framework could actually start to apply changes to your data store. And these systems are not always made for clustered environments or master-slave replication environments. It's not topology aware. So it will just apply the schema change because it is necessary for it to function properly. And all of a sudden, your application grinds to a halt. So this is something you need to be aware of and you can work around. And if you would work closely together in DevOps, you would foresee that there's a change going to happen. So you could actually work with existing tools like Percode Online Schema Change and Ghost by GitHub, and then provide this in an automated way. And the last thing that I've mentioned earlier was version upgrades. Once you have deployed a new data store, newer versions come by nowadays more often than previously. And most of these newer versions contain bug fixes or resolve vulnerabilities. So there is a need to upgrade regularly. However, in my opinion, upgrades or updates actually are not applied often enough. And the reason why is because you want to retain the high availability of your service. That also means that you have to work against that. There's a difference between minor and major versions. So you have like the upgrade to a major version, where the major version actually may require dumping and loading of data. This is, for instance, with MySQL 5.6 to 5.7, they actually require you to dump all your data in a logical backup and then load it again. So that may be an issue doing or performing that upgrade. Minor versions are most of the times in-place replacements. And we have, I think, a nice webinar about that by our colleague Christoph. Upgrades are normally routines for sysadmins and DBAs. They are quite experienced with performing upgrades. However, for DevOps, that may not be the case because they most of the times are not upgrading the backend database systems. So it may be a good idea to automate as much as possible and make it easy for them to apply this. And then what I said earlier, the high availability needs to be retained. So what you normally would do in a master-slave environment is upgrade slaves first, then promote an upgraded slave to become the new master, failover, and upgrade finally the master to the latest version. And then you have like an in-place upgrade. You could also use things like load balancers and proxies to divert traffic from nodes that get upgraded. Otherwise, you would have to change configuration files. And of course, prior to performing this upgrade, you need to test your upgrade scenario. I mentioned automated failover in the previous slide. This also happens without upgrades. Microservices and DevOps should be aware that automated failovers may happen. However, in the topology that is currently configured, it's the question, how are you going to perform this failover? So, for instance, a master node would fail. That would make a slave promotion necessary, but it might take 20 seconds to happen because at first something has to identify that the master node has failed. So that takes like maybe 3-4 seconds to figure out that the master is now gone. It needs to do something with the action to promote this one of the slaves. Then you need to elect which slave needs to be promoted. And that also means that you have to look whether the slaves are all in sync before you actually make the new topology and promote one of the slaves to become the new master, and all the other slaves realign them with the new master. And that may take up to 20 seconds to happen. So what are you going to do in between those seconds? And then the failover handling is also how would you do that? So a very popular method is providing all the nodes in a config file, and then have the application discover the topology itself, and then handle that failover by the application itself. You could also use a resource manager, like, for instance, etcd, where you provide a topology to the application, and then etcd or Zookeeper would know actually what the topology would look like. And handles the failover to the application this way. You could also do it with, for instance, a replication manager like MHA that does a similar thing, but then use, for instance, virtual IP addresses. Or you could provide a load balancer or proxy to provide the connections to the application. And most of the time, the load balancer and proxies are aware of the topology, and then they would automatically fail over to the new master. Or if you have a slave that needs to get all the read traffic, it could also handle that. Final point of interest is the Chatbox integration. I've spoken about getting the information out there, making pages with all sorts of graphs. But communication is more important than just providing graphs, because graphs are just interpreted by the users. To improve communication, you would, for instance, use, in this case, ChatOps. So you have already your chat environment inside the company. So create a separate channel for a specific team, and then enrich those channels with all sorts of information like metrics, alert status. And this is what Riaan mentioned earlier, that he has a separate channel made for all the errors that come in from collect D or from New Relic. And then once you have such a channel, everyone can keep an eye on that channel. Something pops up, apparently something is done, and we need to take evasive action or do something about it, or just leave it as it is. What you could also do is add database commands there, make a chatbot, for instance, by adding backups to this ChatOps channel, where you can actually make a backup of your dataset pre-deployment. So if you have deployed a new version and something goes wrong, you can always revert back to the previous backup. You could also do schema changes from this channel. GitHub is one of the companies that created Ghost for this, that they could actually perform all these schema changes directly from their chat channels. So it's really helping a lot having all these tools collectively inside one interface. Data distribution, I mentioned that earlier in the microservices, where, and that's also important to know, and this is kind of preparing for what Riaan is going to talk about in AWS. Your data may not be in the same location anymore with the current cloud strategies. Once these microservices get deployed in, let's say, a cloud environment, that could also mean that in the cloud environment, they are in different data centers or in different regions. And that also means that a lot of information has to go through a wide area network. This gives you new challenges because that also means that it may not always be available for the microservice to contact another microservice. It also means that disaster recovery is more important here because if data center A would go down, you need to do a disaster recovery of data center A in data center B. You may also face other issues like uneven storage usage, and that could be created by, for instance, sharding. Sharding will actually separate your data, and microservices are basically functional sharding by service themselves, so that data gets separated by function, and one data store may actually be larger than the other one, and that also may give you different storage needs per service, or maybe a different data store per service. Then there's horizontal sharding for the services that are outgrowing their current data stores. So for instance, you have a MongoDB replica set, and it becomes larger than actually the database host can manage. And then you could apply functional horizontal sharding, and then provide uneven spread of the data. However, then you are spreading your data over multiple data stores. Of course, you want to manage data stores like this, and for this you would actually need to manage your data flows better by using, for instance, a load balancer or proxy. And this could be either a Maxscale proxy SQL or HR proxy in the case of MySQL, or in the case of MongoDB, you could use the MongoDB routers for providing as a load balancer layer. And this way you can also abstract the whole sharding away from the microservice storage layer. And for the storage layer of the microservice, everything is just one simple big connection to a pool of database servers, and it doesn't have to know anything about the sharding. Before we head into the cloud automation on the AWS by Riaan, we also have the next poll to ask you.
Yeah, thanks, Art. Yep, thanks, Art. Yeah, and because we're talking about cloud now, we wanted to ask all of you in the audience how you currently maintain your databases in your company, or where you work, whether it's on premise or whether you are on a cloud environment, or maybe it's a mixed environment, which nowadays is kind of the most likely scenario, or some other scenario. It'd be great to get your feedback here. I'll just let this run for a few seconds, and also just to remind you that you can ask us questions on today's content at any moment by using a question section of your control panel. We'll take a few minutes at the end of the webinar to go through these questions with you. But for now, thanks for your participation in this poll. I'll just let this run for a couple more seconds. Thanks very much. And I'll just close this now and share the results. Great. So it looks like the majority of you, actually, I mean, there's multiple answers to this question, but the majority of you looks like you're on-premise and then cloud environment and mixed environment. So it's pretty even, actually, which is interesting to see. I don't know, Riaan or Art, any comments on this before we continue?
It looks pretty much like the normal scenario. Some people host some stuff on premise. There's looks like there's a move to the cloud, which is always nice. But in South Africa, specifically for us, we cannot move to the cloud yet for our Reserve Bank regulations. So I know in Russia as well, there's this data retention law, and then you have to either host it on premise or you have to host it in a data center in your country.
Okay, interesting. Yeah, I've had similar feedback also from some financial institutions. They wouldn't go to the cloud for similar reasons. Mostly because it's got to do with restrictions or rules that apply for particular industry sectors. So that's interesting to hear. And I guess different countries have different regulations as well. But good to hear. And thanks everyone for your participation in this. I'm just going to hide this now, and then we'll get back or hand over to you, Riaan.
Thank you very much, Jean. During his presentation, Art highlighted a lot of things like failover, getting an environment up that closely matches your production, maybe get an environment up for developers, and so the journey of DevOps, we use a few tools, and I thought I'd start with just the IDE I use. I use Atom. It's very lightweight. I use Ubuntu as well on my desktop. And what I like about Atom is it's just natively, there's an app for you to develop in. And it comes with a plugin kind of architecture. One of the plugins I use is Hira YAML, and that just lets you encrypt data very quickly and easily. So then once I've got my data, my credentials encrypted and stored on Hira, I also like to share them securely. And for this, I use a quick browser extension called Mailvelope. And I encourage all of my teammates to start sending encrypted emails. I mean, so often it's just easy to quickly just send a password. But then, I mean, later on, you see this password in an email chain pop up. And yeah, that's where everything begins. Art, could you go to the next slide, please? So once we encrypt it, once we add our data into Hira, it will look something like this. You'll have a DB hostname, you'll have a database name, a database user, and a password that we encrypted. Earlier on, I mentioned this composer package .env from vLucas. I use that. You don't need to be a developer to make use of this package. Most of these frameworks like Magento and Symfony framework and Laravel comes with these autoloaders. So we just tell it where to look. And for this, I use Puppet to just write a simple .env file. And this then gets loaded into the application. So it doesn't matter whether the developer is on Vagrant or a staging host or a production host. In his code, you will always just deal with the variable name db_host. And that just makes it so easy to manage credentials. In Hira, you can use different environments for stages, and these credentials then differ per your environment or per your stage. Art, if you could go to the next slide, please. So Art has mentioned how do you get these databases up and restoring from snapshots. I've put together a little gist for you. It's a CloudFormation template written in JSON. But what this template will do is it will launch an Aurora cluster for you with 2 nodes. It will launch a MySQL instance for you with just 1 node. It will launch a Redshift database for you with 1 node. A Memcache NoSQL database, 1 node, and a Redis database with 1 node. The thing I would like to just highlight here is that no journey in DevOps starts, I think, to me, should start with application in code. DevOps cannot do things manually anymore because we don't know always, like Art said, DevOps aren't that skilled as a database, a DBA. So for us, it's very important to keep these details in code so that we could later on look at this or find help or even collaborate with pull requests or branches between developers, DBAs, and DevOps. That to me is very important. So naturally, everything goes in code. Everything I do goes either in CloudFormation or Terraform, and then I would use Puppet or Ansible to manage these resources. Art, if you could just go to the next slide, please. So I thought, how would I quickly show you how to manage these resources? There's a lot of modules on the Forge. There's a lot of chef code out there, but I thought I'd show you a simple, just some Puppet code that uses command line that you can either use in a bash for loop, or you could use in Ansible, or you could just use this as a base to get your own Puppet code out there. Just to show you that it is not impossible to start managing these resources out of code. So we have a Hira hash, profile MySQL servers, and we add some identifier name to that, and we give it an endpoint, and we give it a username and a password. These credentials we get from our previous template that CloudFormation will create, and these are the credentials that we specify in that template. We then use those credentials to populate our hierarchy. We tell it that we want some databases present or absent on these resources. For this, I then take these credentials, and all that I do is I populate a .my.cnf in the root folder of your management node. This is very handy because you can now, via the command line, interact with your databases, or you can use Puppet to interact with your databases. You can use MySQL dump with a ---- group suffix. So we now create a quick my.cnf. And Art, if you could go to the next slide, please. I will show you the Elastic ERB template, and it's just about 6 or 7 lines. All it does is it loops through these servers hash that I pass to it. I extract some data. I set a little comment. So on the command line, you can use MySQL ---- defaults -group -suffix equals the identifier that we specified. And then below it will add our, our details for us. So we can then, just by doing MySQL ---- defaults group suffix and our identifier, we could quickly connect to these endpoints. Once again, these endpoints could either be on-premise, we could just make it available by exposing this port on our router or firewall, or they could be in AWS. They don't have to be in the cloud. We could start immediately with what we have. Art, if you go to the next slide for me, please. Now we have a quick define type. And all that this does is it uses the Puppet exec to check if a database is present, and if it's not present, create it. So you can do this with a bash for loop. You could use Ansible. I have just used Puppet, but you can extract some of this bit of information to do it for yourself. Again, when I started, it didn't have to create these databases. I could just notify that this database is present or it's not present. So I could test completely the code without affecting anything in the meantime. I could just check whether this database is available, and if it's not available, I could push a notification that Puppet is about to create this database. Once I'm entirely sure that this works, and I've tested it on Vagrant, or I've tested it on some copy of the production snapshot, and I'm entirely sure that it works, I can now roll this out to production. And all of a sudden, my databases are now automated. I can create and drop databases. And just using a simple example like this, we could also then create MySQL users. There is a Puppet Labs MySQL module that you can specify very fine-grained grants permissions per endpoint, per database, per user that I also use for my Vagrants to use. And I encourage you to just go have a look at it. Puppet Forge modules enable you to get up and running extremely quickly. It has been thoroughly tested by the community. A lot of these projects are hosted on GitHub. So if you have any problem, you could fork it. You can make a PR and then push your patches back upstream. And that is basically my bit on AWS database launching and automation. Art, I'm going to pass it back to you now. You guys are welcome to ask me some questions after the presentation. Thank you.
Thank you, Riaan. Before I'm going to do a demo, we still have one final question to ask.
Yeah, thanks Art. Thanks Riaan, and thanks Art. I'm just going to launch this. This is the last question for today to all of you in the audience. But seeing that Riaan just talked about Puppet and Chef, and I don't know if you mentioned Ansible or not, but we just want to see what tools or systems you currently use yourselves to automate your database infrastructure. Of course, we just talked about cloud in particular, but we also saw that a good few of you are working on premise, so it'd be good to get your feedback here. I let this run for a few seconds, and then I share the results. Thanks very much for your participation. Great. So not too unsurprising, but a lot of you, or most of you, are using in-house scripts, which is still very much the case. I know we have a lot of DBAs today in the audience, so maybe that's not too surprising then. Then a good few Ansible and Puppets. Nice to see some classical control and Chef in there as well. So it's a good mix. And on that note, we'll be coming out with a new release of classical control with AWS support in a couple of months. So look out for that. But Riaan or Art, any comments on this on these results here?
Well, I kind of expected Puppet and Ansible to be the most frequently used ones. In-house scripts was a bit surprising, but you can also use that alongside Puppet and Ansible and Chef.
Great.
It's a good mix that I see here. I love actually the in-house scripts. And I just want to say that a DBA is only something that someone has given you a title. I don't think a lot of times you find sysadmins say that they are not developers. And I want to disagree with that. We are all developers. Even my wife, when she writes a shopping list, she's a developer because she uses small little code, 2 times abbreviation, milk, or something like that. And I think sometimes we scare ourselves into talking ourselves into what we can and cannot do. So for me, it's a great start. If you use in-house scripts, wonderful. Any bit of automation that you do will really, really benefit you greatly in the long run.
Excellent. Good stuff. Thanks, thanks Art, Riaan, and thanks Art. I'm just going to close this now and then hand over to you, Art, for the demo.
Okay. Let me exit this one. Can you see the demo right now, JJ?
Yeah, looks good.
Okay, good. So what you're looking at is my demo environment of cluster control. We have 4 clusters defined here. And normally this is where the DBA lives, and you could provide access to, for instance, developers by going to settings and then user management and giving them an account to log into. But of course, that takes like an extra step. What we actually have in the latest version of cluster control is something called integrations. And the cluster control integrations allow you to create, in this case, communication to another channel. So that would be, for instance, PagerDuty or VictorOps if you want to get alerted on certain things, or go to Telegram, Slack, or use a generic webhook to communicate with some other framework. And then what we basically do from cluster control, and I can show that, for instance, with Slack. I already have a Slack integration. I'm going to demo that later. All we need is a URL to post our messages to, and then that communication channel will be able to display that. So advancing to my tab here, you can see that in this demo Slack channel that I created, we have some sort of alarm here that was created from cluster control. I would be able to do that right from here. If I would send a test message, it actually ends up here as well. So whenever there is an alarm in cluster control, let's go to my activity here. So we have an alarm here, system time is drifting. If I would have enabled, instead of all critical events, also the warnings, this would have ended up in my demo right here. And that obviously gives you the ability to create, in this case, I have sent everything to general, but I could create a alarm channel that everyone would receive all the alarms coming from cluster control. What we also spoke about is a chatbot, and for several nights we created a chatbot for cluster control called CCbot. And CCbot at first had a lot of functionality, so I can use, for instance, here help on CCbot, and it shows you immediately what you can do. You can list clusters, you can ask status from the clusters. You would be able to create backups immediately. However, we also have a command line client since cluster control 1.4.1, and command line client allows you to also deploy systems. It also allows you to show, and that's what I'm going to show right now, cluster minus list. I'm going to show you the overview of the cluster. And in this way, you would be able to use, you could also use minus help on that command, and it would just give you like the output of all the commands that you can send. And this is only the cluster related messages that you can create, but we also can make backups directly from the command line client. We can deploy new clusters. We can add nodes to clusters like here, or remove nodes. So it's a really flexible tool, and this way you would empower anyone having access to the chat client and the chatbot to operate cluster control directly from the chat. So you don't need to log into cluster control anymore if you are a developer and you just want to deploy a new node or make a copy of the existing data set. That concludes the demonstration that we wanted to give on cluster control. We're also near the hour right now, so I'm going to go back to our demonstration, or to our presentation, and then we can advance to the questions.
Cool, thanks a lot, Art. Thanks for this demo. Yeah, and feel free to ask any questions in the question section of your control panel. I don't know, Riaan, any comments on what you just saw? I saw that you were sending something through in the chat.
Yes, I just said that looks amazing. You know, any company that takes advantage of these integrations in today's date, I mean, they will certainly reap the rewards. The time is ripe now for these integrations and to just create these feedback loops. Where 5 years ago, this was a very different story, eh? Art, I mean, 5 years ago, what could you share it with? Like a Skype maybe and an email. Now we have Slack and GChat and Hangouts and Alexa. Times do change quickly, eh?
Yes, it does, and especially the collaboration that you can do now from a chat client. Nobody would have imagined that like 5 years ago. I think 5 years ago, people saw Skype as an annoyance.
Sorry, Art.
Sorry to interrupt you. I was saying that 5 years ago, everyone saw Skype messages as an annoyance, as a distraction of performing your job.
Exactly, you know, and I would almost want to bet that in 5 years from now, there will be no more programmers or DBAs or system administrators. It will just be DevOps, you know, everything will be in code, and there will, I mean, things will just change. Everyone will be a coder.
Yeah, I agree with that.
Well, we heard it here. So, there are no that is where things seem to be going. That's for sure. That's for sure. Thanks, thanks, Riaan, and thanks, Art. Can we just go to the next slide where we have some resources that we want to point everyone to?
Something went wrong.
Great, thank you. First of all, there's Riaan's blog or website, riaannolan.com. Feel free to check his details out there, and you know what you communicate on over there. Riaan, thanks for sharing the link. We've got a new white paper on DevOps that we just published yesterday. If you want to check it out and go and download it from this link, you can download it for free here. It's all around how to automate and manage your database infrastructures from a DevOps perspective. So feel free to have a read of that. We've got our DevOps blog, and you can also go and check out the cluster control command line interface, which Art just showed us in the demo by using this link here. And we're just on the hour, so we're pretty much done for today. Thanks very much for your participation. Yeah, happy Nelson Mandela Day. Back to you, Riaan. Thanks very much for joining us today and for talking us through your view on what DevOps is and how it works. And thanks, Art, for the presentation and the demo. Riaan, any final comments before we finish?
No, I actually thoroughly enjoyed this presentation. Art, thank you very much for your insights and your experience and just sharing this with everyone. Certainly, I'm going to use some of the things you've highlighted. And yeah, everyone, I just want to wish you in person a very happy Nelson Mandela Day. Do something for a stranger today. Do something nice for a stranger today.
Thank you very much, Riaan.
That's a nice message. Thanks very much. Thanks, Riaan. Sorry, Art.
No, I was saying.
What you want to say? Good stuff. Good stuff. Well, then, thanks very much for today, everyone. Thanks for joining us. We'll share the replay and the slides tomorrow. And have a good rest of the day, a good Nelson Mandela Day. And yes, let's do something nice today for someone we don't know. That seems like a good plan. Thanks very much, and we'll talk to you soon. Take care and have a good week. Thank you. Bye-bye.